Good evening, everybody, and welcome to episode number 10 of Super 30. Super 30 is a 30-minute session that's held by RATA in partnership with CEEW, primarily focused on the policies that can impact the HVAC&R business. It's an informative session, short and sweet, and keeps you updated. And please remember, knowledge is power. The more you know about what's happening around from the policy factor, you are much better prepared to handle the business. And for RATA, we are 73-year-old Refrigeration and Air Conditioning Trade Association. Well, we represent close to about 1,200 companies. In total terms of turnover, close to about 10,000 crores of business and close to about 65,000 employees, focused only on the growth of the MSME in the HVAC&R segment. So today's 10th episode is all about the Kigali Agreement, and the India perspective to it. And to tell us about it from CEEW, we have Mr. Jitendra Bambure. Hello, Mr. Bambure. How are you doing?
Hi, how are you? And welcome to meet all of your members again. I'm glad
Thank
to
you
do
so
that.
much. Well, our members know you pretty well. You are a well-known person within our industry. But just for a quick introduction, Mr. Bambure has had over 4 decades, and he's held various leadership positions over the last 4 decades in HVAC&R and the appliances industry. His areas of expertise include product strategy and management, technology strategy, setting R&D center, product development, quality and manufacturing engineering, productivity enhancement, value analysis and engineering, cost reduction, vendor development, change management, leadership development, and international business development. A person who most of us in our industry is well aware of. He is a thought leader and has always stepped ahead to share information. So today, as an advisor to CEEW, he's here to share with us a very important topic on India and the Kigali Agreement. So, Mr. Bambure, all over to you. The stage is yours.
So good evening once again to everybody, and thanks Ajit to give this opportunity to share my thoughts on this important subject, which is broadly known, but I'll try and bring the finer details of it. So Imanshu, the next slide. Yes. So I work with CEEW, which is amongst Asia's leading policy research institute. It uses data, integrated analysis, and strategic outreach to bring out what possible change and make aware all the stakeholders. The CEEW works in energy, renewables, power sector, industrial sustainability, low carbon pathways, risk and adoption, technology, finance, and trade, which they have been working on these areas in multiple ways. As I said, CEW is a Council on Energy, Environment, and Water. So today's information is also based on, we can say, environment. Next slide, please. So this, we all know that refrigerants are useful to humans, but not in the long term because it causes it has got many implications. To just just to understand what it is, the CFCs, which are now already phased out, were originally developed way back in 1930, and and its compounds, especially the CFC11 and CFC12, find a good use in aerosol spray, propellants, solvents, and flame blowing agents. These chemicals have excellent properties. Why they were adopted? Because they have excellent properties, stable, cheap, non-toxic, and non-flammable, and very easy to produce also. And that's why they reached out to everything, whatever application could be. From our perspective, from HVAC perspective, they were used as refrigerants and as blowing agents in the foam sector, which we use for insulation in refrigerators, cold rooms, and others. However, Frank Rowland, an American Nobel laureate and a professor of chemistry, and Mario Molina, a Mexican chemist who discovered the Antarctic ozone hole. We all know that ozone hole has created issues for all of us. Developed an theory which linked CFC's use with ozone depletion, and they got Nobel Prize for that. And a joint research by them was published in 1974 and awareness in 1978, which led to in 1980 a Vienna Convention and the Montreal Protocol allowed for a global regulation of these chemicals. Next slide. Now, how was Montreal Protocol designed to save the ozone layer? The Montreal Protocol on the substances that deplete ozone layer is a global agreement to protect Earth's ozone layer by phasing out these depleting chemicals. So what happens is these chemicals rise and stay in the uppermost atmosphere of the Earth, where they react chemically and break down the ozone molecules with use of sunlight, and with that the UV rays natural filter goes off, and the harmful UV rays reach the earth, causing many issues. This phase out plan includes both production and consumption. So and it was brought in 1987 and entered in force in 1989. 197 member countries to this protocol have agreed to the treaty and have been completely ratified to ensure that the ozone layer is protected. The fundamental principle here is common but differentiate responsibility, which means that the Article 5 countries, which are, we can broadly say, as developing countries, have a deferred phase out plan as compared to the developed countries. That means the responsibility is common but differentiated. Why this was done? It was done to ensure that their growth in terms of the providing comfort, food security is not impacted. Next slide. So Montreal Protocol has proven to be a success. It is one of the most successful a treaty which has been adhered to by all the countries, and it works again in the principle of consensus. Never it has gone into like voting and majority. Every country has agreed to this. Now, how do we differentiate? We said that developing countries and or Article 5 countries as developing countries and other developed countries. It has been done on per capita consumption of the refrigerant, which is 0.3 kilograms per capita, and that is the fundamental point whereby it gets differentiated. Now, Article 5 countries are allowed to delay the implementation of control provisions and are eligible to receive assistance under multilateral fund. So it is not only the delay, but the multilateral fund, which is funded by the developed countries, allows a fund to be available to the Article 5 countries so that they can invest in technology or invest in changeover. And these benefits have been taken by almost all the countries. India phased out CFC and is in process of phasing out of HCFCs. As such, HCFCs is popularly, which we know as R22, has been phased out in room AC and getting phased out in other systems. This has successfully curbed 92% of production of chlorofluorocarbons and other ODS, significantly contribute to the repair of the ozone cell. We know that ozone hole, which was big, is now started shrinking. HFCs are commonly used substitute. Then when HFCs were to be substituted, HCFCs were to be substituted, HFCs are commonly used to substitute which don't have ozone depleting potential. However, with the use of HFCs, they have the global warming potential much higher, 1,000 times that of carbon dioxide, and this triggered that something has to be done now to reduce the global warming to 2 degrees centigrade to the pre-industrial era. And that is why the Kigali Amendment, which is the 18th Amendment, came in 2016. Next slide. So what will happen? So 15th October 2016, the Kigali Amendment came to the Montreal Protocol, and uh, the analysis and predictions and hypotheses show that if we phase down the HFCs, it is possible to control the rise in temperature by 2100 by 0.5 degrees centigrade, which means that it is about, you can say, if you have to control by 2 degree, control up to 2 degrees centigrade, Kigali Amendment and the control of HFC itself will contribute to about 25%. The Kigali Amendment says that by 2045, the it will not be phased out but phased down to 80 to 85% of their respective baselines. We'll see what are these baselines in the subsequent slides. Next slide. Now, Kigali Agreement has got three groups. I had explained to you that there is an Article 5 countries and not non-Article 5 countries. The first group, which is non-Article 5 countries, is USA, UK, UE, EU, and countries like Japan also will start phase down of HFCs by 2019, which has already started, and reduce to 15% of 2012 as their baseline by 2036. So the process here has already started. Now, in the Article 5 countries, which is the developing countries, this has been segregated into two groups. The second group consists of China, Brazil, as well as some African countries, and will start phase down by 2024 and reduce to 20% of 2021 by 2045. Now, the third group, which consists of developing economies but have hottest of the climate countries like India, Pakistan, Iran, Saudi Arabia, will start from 2028 as their baseline and reduce to 15% by of 24-26 average till 2047. Now, you may ask why this happened. This happened because alternatives to the existing refrigerants which are used, like 410A, 134A, and 404, are not easily available, and research is required what will be a good refrigerant in high ambient condition, and that is the reason why this third group was formed. I would also like to add here that in Kigali Amendment, it is agreed that the whatever new refrigerant will be used or will be adopted should not impact the efficiency of the unit. Otherwise, we will reduce the the global warming due to direct emission of refrigerant, but the life cycle cost should not also get impacted. So if the efficiency drops, that means it will be using more electricity, which is generated from fossil fuel, then it will start nullifying the effect. So that aspect has also been seen. Next slide. So this is a broad statement or what you can say, a graphical view, which we can say here that the orange line is the first to go off. The green line is the Article 5 countries, which is China, Brazil, and other things, and the India, Pakistan, and Middle East country, Iran and Middle East, is the light blue line. Next slide. Now, India perspective on Kigali Amendment. India played a very flexible and cooperative role in the whole negotiating process. I would like to share with you that I've been witnessing many of these negotiations and discussion, and India is a very well respected, and Ministry of Environment and Forest plays a very constructive role to ensure that there is a balance between environment protection as well as the interest of India in terms of its growth and not getting adversely impacted because of the stringent regulations that will be made. So what has been agreed? Now, India consumes only 3% of the HFC as compared to other nations, like USA is 37%, and China, though it is in the developing nation status yet, it consumes 25%. And India's perspective was well heard there. Uh, Having said so, it would be a tough for Indians to adhere to the agreement along with the Paris Pact, because we have already made some voluntary commitments in Paris Pact, and then in COP26 in UK we made some voluntary commitments. Because these both the things have to be seen together. Also, it is because important that we have taken an ambitious plan of Make in India. That means the and the growth is going to be very high in India, which means that the consumption in next 20 years or so is likely to be high, and will the penetration in India today's of air conditioners is only 8%. We know that the cold chain is yet to be fully developed, which will mean that there is a lot of requirement for the air conditioning equipment. Growing demand of air conditioning, and this is also triggered by growing middle class. Still, as a responsible nation with a global perspective, the Indian government has voluntarily passed an order to stop the production of HFC 23, which is by a byproduct commonly used. This will reduce the emission by 100 million tons, equivalent to carbon dioxide, in next 15 years, which is a big one. Next slide, please. This graphical representation shows how the transition has happened. So we have got CFCs, which is high ODP, ozone depleting potential, as well as high GWP. Went to HCFC, which had moderate ODP, high GWP, which both the things are already in the phase out list. And then we have got HFCs, which has got zero ODP but high GWP. And these are what we call as the hydrofluorocarbons. And then we have got the next generation that is coming in is HFOs, which have got zero ODP and low GWP, and of course the natural refrigerants, which are mainly carbon dioxide, hydrocarbons, and ammonia. But ammonia is toxic, and hydrocarbons are flammable. Carbon dioxide, with the ambient conditions of the nation, what we have is it will have its own challenges to adopt. So if you look at the Europe is going towards natural refrigerants in next 3 to 4 years. US and many others will move towards HFOs. Next slide, please. So what might be a sustainable refrigerant is one of the candidate is HFO, is what we saw, and why in which of the HFOs. So HFOs, why they are, because they have got a very short life cycle in the atmosphere. They last for only say 2 to 3 weeks upper limit, and then they break down, and that is the reason they don't stay in the atmosphere for a long time and don't impact the environment. HFO 1234YF has physical properties very close to HFC 134A, which is used in refrigerators, which is used in deep freezers, which is used in chillers, and many other applications. And it has got all good properties, like it is low toxicity, low GWP, like 4, which is against 134A has around 1400, and 410A has around 2100. Low total contribution to climate change, and the physical properties are such that the operating pressures are very similar to that of HFC. So product design, you can say not much of product changes have to be made, and it can be, of course, fine tuning is required, but it is more close to, we can say, as a drop-in. Next slide. So if you look at a closer look of GWP, how it is and what it is. So HFC phase down under Kigali amendment will be measured in ton CO2 equivalent. So all refrigerants who have got different values will be converted into CO2 equivalent. Parameters is calculated to give a flexible approach to HFC phase down. So each country can really decide of which HFC they can keep depending upon the availability, which they can phase down early. But as we said, as the average of 24 to 26, and those numbers should be brought it down. So like as I said, F410A has got 2100, and which means that it has got 1 kg of 410A is equal to 2100 kgs of CO2. And this is the type of impact. Next slide. So how it is calculated? There is a simple formula here. Like CO2 equivalent is calculated as mass in tons. Say for example, if 100 kg of 404A is to be carbon equivalent, CO2 equivalent is calculated, mass in tons into GWP, which is into GWP mass. So it comes as 100 kg of 410A is equivalent to 0.1 as mass, and 3922 tons of CO2, which is 392.2 equivalent CO2 tons CO2 equivalent. So this is the in this way a cumulative of all the refrigerants will be worked out, and that will be put into that phase down schedule. Next slide. So what will happen is the parameters of CO2 will be worked out, and production and consumption targets will be set against this CO2 equivalent, which will be like a freeze, which will be starting from 2028. This approach allows each country to plan their phase down in a way that best suits them. So it is not that all across the world all the refrigerants will be phased down or phased out. What will happen is each country will then decide what becomes easy for you. For example, in Europe, most of the application are refrigeration. In Middle East, they are air conditioning. In India, they are both refrigeration and air conditioning. So this will give the flexibility. The baseline of HFC phase down calculated is based on combination of both HFCs and HCFC consumption. So why HCFC? Because HCFC will also be used for servicing sector. It is not that it goes only in new products, but it will also get into servicing sector. So that is why a combination of both is used. Next slide. Now, this chart is extremely important. What we can look here is that the bullet point number 5, which says that to achieve an 80 to 85% cut in HFCs, it will be necessary to adopt HFCs which have an average GWP around 200 to 300, which is something the third from the bottom, which is it says low 100 to 300, and this is what is the real difficulty, because we will start with the high GWP between 1000 to 3000 are mostly used today, 134A, 22, and 410A. And though R454A and R455A have been mentioned there, it is the availability, the design development, the availability of compressors is yet to be matured. They are all at a design phase mostly. Of course, if we go down like ultra low, which is HFOs and R290, then it becomes easy. But the challenges of these are in the equipments like the VRF, where high demand is there. Next slide, please. So this is what I wanted to explain to you, and I look forward for questions.
Thank you, Mr. Bambure. Just a quick question. We have about 5 minutes to go. I mean, in that whole chart on the severity of refrigerants, you said that the ultra low was about less than 30, and that's R290. Do you see this practical even in the Indian context? I mean, you spoke about the servicing sector, you spoke about safety. I mean,
yes,
you understand the safety challenges. Do you think it's practical, or which way would India go?
So it is like this, that if it is used in a small numbers, like 50 grams, 100 grams, it is practical, because it is being used in domestic refrigerators for a very, very long time. All Godrej refrigerators are with R600 or R290. Many deep freezers manufacturers have started using it. So again, it is the charge quantity is from 50 grams to 75 grams. It is manageable in all respects. Even if it leaks, it is not, the potential hazards are less. It is possible for the service technicians to carry it. But a large systems, we know that Godrej did introduce 290, but nobody else. And in the larger systems like ducted systems, cassettes, more than 2 ton of air conditioners, chillers, VRF, it looks very very challenging. The charge quantum itself doesn't allow to use it, and Europe is trying to adopt it, but it is not going to be easy for them. The safety will be a biggest concern for the customers, and more so for the service technicians, because they will be handling these refrigerants.
So this is from new equipments, and what is the impact of this whole policy related to all the equipment that is already installed, which is primarily focused more about the servicing and the replacement market? Because on one hand, you're saying that the industry is going to scale up 8 times, the demand is going to increase 8 times, but also there's a huge opportunity lying that all these old refrigerants need to be replaced. So, to what extent will the servicing sector get impacted, or the installed machines with old
So
refrigerants
installed
get
machines, we
impacted?
can say the largest installed base is on room AC, which is about 80%, as computed by in ICAP, and most of them will, uh, if you take today, by 2032, 10 years down, will have to be replaced, because usually the design life is somewhere between 10 to 12 years. And there will come the biggest challenge of how do we recover that refrigerant and how do we dispose. There is no what you call as the uh, economic incentive, not incentive, economic viability is not there of recovering the refrigerant. That is something which CEW is also looking into. But yes, it will be a huge challenge, because there will be a variety of refrigerants that will be coming in. And so this is one, which is a replacement. The second one is, when the new units will come in with the new refrigerants, how do we serve the units which are already in operation, and if they leak, and if we have to service them. So the huge challenge for the service technician is they will have to handle multiple refrigerants, and they have to carry multiple cylinders with them. In case of flammable, there are regulations that they can't carry by public transport. There is a limit on what can size, or I think it is they can't carry a refrigerant more than 200 grams or something, or half a kg. So these will be
Not
the
allowed
huge
at all.
challenge.
It's not allowed at all, because
Yes,
they don't let you. I
and
mean, small cans also,
and
they,
the
anything that's pressurized, they are very touchy about it.
correct. And the biggest challenge will be, how do we reach out to so many technicians and make them aware? I'm avoiding the word training, but how do we make them aware of the performance, pressures, different type of refrigerants that are there, and there'll be huge variety of refrigerants filled unit that will be running in the market.
True. So, from a perspective of the technicians, he's going to now handle different refrigerants, different cylinders. Even he'll go to one site, he will have equipments of different refrigerants. You really think
Possible.
we are anywhere close to be prepared with our workforce?
We are
No
nowhere.
certification? We are nowhere.
So
So,
this
you
is
clearly see
not
this
this
as a
is
huge stumbling block and a challenge.
Yes. So, and I would like to share with you that, because I'm working with refrigerant options technology, refrigerant technology options committee, and technology and economic assessment panel, and this is a problem not of India, but including US, EU also, but more so India, Argentina, Middle East, Southeast
Developing
Asia,
countries.
Africa. Huge problem, and they are not found, they're not able to find a solution to this.
Amazing. Yeah, I think we have a huge problem to solve there. And Mr. Bambure, that's just about the time we've had for the episode number 10. Thank you so much for that wonderful information that you shared with us. Very informative. And to all our members, these sessions have spoken a lot about the policies that can have a direct impact on your business. Often, when you're sitting and doing business, you tend to not have access to such information. So, at the association, we're very fortunate that CEW has partnered with us in sharing these informations. At any given point of time, if you want to go and visit any of these episodes, just visit the website rataindia.com. Go to the event sections, and you will have the recordings of all these sessions, which you can revisit or you can share with your team, so that everyone is well informed. So thank you, Mr. Bambure. Thank you very
So
much.
last point, Ajit, I want to make here is, uh, people who are operating, they require the definitiveness in what they want, so they can plan. But unfortunately, here nobody knows which refrigerant is going to stabilize after 10 years or even after 15 years, and that is the biggest challenge for everybody.
Amazing. That's true. All right. Thank you so much. But gentlemen,
Thank you.
uh, before we close, remember we have a huge conclave coming up. That's on the 16th of September 2022. That's being held in Delhi. It is the first RATA conclave. This conclave will have over 300 business owners from across the country who is joining us. So if you haven't done your registration, please remember, out of the 300, we are already sold out by 200 tickets, all paid tickets, and there is about 100 left to go, and you have a month more to register. So don't get disappointed. Go online to the website, register, and attend this event. This is the first event for business owners from the HVAC&R industry, the largest conclave ever that's being held in Delhi. So thank you very much for joining us, and hope to see every one of you at the conclave.